are all extremely lucky to hear from Rex Alexander, who has been on the line for first response for a couple of years, I'll say. One or two years. He really is a formidable presence in emergency response, brings you the boots on the ground expertise, or I should say boots in the air expertise. Nidhi, I believe, has his whole, are we doing your whole fabulous introduction? Yeah, okay, no, Rex says we're not, just trust, well, you've probably heard from Rex before because he's been an expert for a while, Rex is the real thing. So as all of you are building for real world situations, Rex is the one who actually will deploy with it. So listen up, learn from him. We are thrilled to have Rex as a fabulous speaker here. Thank you.
Well, I hope I can live up to all that hype. All that experience just means one thing: I'm getting old. So a little bit about, where I come from and what I try to bring to the table. I'm talking with Gwen and the team at GoAERO. I've been collaborating with them now for a little while. So from the piece that you're looking at, which is the air medical or search and rescue piece, I spent probably right around 20 years in the air medical world as a helicopter pilot. Wore many, many hats, as you can see. In that space, I was a helicopter pilot, I was a base manager, I was a safety manager, I was a regional manager. So I had one base, decided I was doing really good and wanted to move up. And then they gave me 28 bases and 115 pilots to oversee. And after about 5 years, I said, okay, I have had enough of management. I want to go back to the line and fly. But in that, I've had the experience of 20 years. I transported in that 20 years roughly 3,200 patients. About a third of that was off-site. So off-site meaning it was a scene, it was a response to a location that was in a remote area. All the others were hospital-to-hospital transports. So I've seen the best and I've seen the worst. I've experienced my fair share of faux pas in the early stages, and to share with you some of those different pieces of the faux pas that I hope that you will not recreate. That's kind of where I was going with today. So we talk about Primum non nocere, which is first do no harm, which we pull that directly from the, God, I'm having a brain fart. It sucks to get old. I'll think of it here in a minute. But when I look at transporting patients, your ultimate litmus test is what's best for your patient. Sometimes I had to learn the hard way that sometimes means I do not go, because if I can't get there because the weather is too bad, or I can't get there because I don't have all the appropriate hardware or equipment or personnel, I don't want to waste the patient's time, get there and then have to do something different, because they could have already been put on some other means of transportation and got at least a portion of the way there faster than if I would have got there and then said, no, we're going to have to call somebody else. So the big thing there is we're looking at what's best for the patient. And sometimes that, like I said, sometimes that's saying no, and that's hard to do when you're in this position. Weather is a big challenge. This is an aircraft that one of my teammates was flying. They got caught in icing, and luckily they were able to put this down at a remote location near a hospital on a pad. Now they were there for 4 days because of the ice, and getting the ice off the aircraft is a challenge after it's been iced up. However, getting into icing as a pilot is one thing. I can see it building on the aircraft. Getting into icing in an unmanned aircraft is a challenge, because what are you using to identify icing building on your aircraft? How do you see icing prior to getting into it? Because I can tell you, when you're in a helicopter, worse even a drone or eVTOL, you do not have a lot of time. The aircraft will build icing extraordinarily rapid. You gain weight really, really fast, and your aerodynamic efficiency goes into the toilet really, really quickly. You have literally seconds to get it on the ground before it comes out of the air. So this is one of those things, and I've been in icing 3 times in my life in 40 years. First thing that happens is the windshield goes opaque. So if you have any visual sensors, expect them to be taken away from you because the icing is going to cover them immediately. That's the first thing you lose. If you don't have some type of heating apparatus on your vehicle, you will probably lose any airspeed notifications you're getting, because those are the second thing you lose is pitot heat and static, or pitot and static port. So making sure that you have an unmanned system, you can see icing far enough in advance that you can slow down and turn around is huge. We get into icing, it happens. The first thing you do is you land. You try not to continue on. If you can turn around and go home, great. I had one instance where unfortunately I knew what the difference in elevations were for the temperature index, and we had a little bit of an inversion. I actually was able to climb up 1,000 feet and go into a warmer temperature layer, and the icing melted off. So knowing what the weather is and having that at your fingertips is huge. But weather is a big challenge. Icing is probably one of the most challenging. Some of the remote locations that you are looking to go into. Having done mountain flying, I can tell you that mountain flying is extremely challenging. So too is urban environments, because you have the architecture of the urban environment, but you also have the terrain of the mountains, which are changing and diverting the winds. So factoring that into your approach to how you deliver care is huge, because when you're getting into and out of certain areas, you have to have certain escape routes. If you get into a blind canyon with your equipment and you're trying to shoot an approach, and the next thing you know, you're getting that mountain wave effect and you can't get out of it, if you didn't factor in an escape route, you're probably going to lose your equipment pretty quickly. So knowing what's going on from an aerodynamic standpoint when it comes to weather and location is huge. Now, weather, we look at what weather will we fly in. So you need to sit down before you even go flying and say, what are we capable of? What is our risk threshold? What are we not capable of? And kind of there's this gray area that you're going to have to sit down as a group and say, okay, at what point do we decide that we don't go? What point do we make the decision, and who makes that decision? That's one of the questions. When the pilot in command is on the aircraft, he is given the authority by current regulations as the ultimate decision maker in the aircraft. Who has that decision for your equipment? Because you don't have a lot of time to have a group discussion. You need to have a set matrix on how that decision is made, when it's made, and how it happens. Risk is one of those things that you really need to pay really a close attention to, is what's your capability. As a group, you basically need to draw a line in the sand. What is the maximum risk we are willing to take? And at what point do we then say, no, we can't go? Communications, weather is probably one of the biggest factors in the air medical industry that I dealt with. Communication is probably number 2. I don't know how many times I've gone out to the scene and we can't talk to the people on the scene. And as a EMS operator, under the regulations that we were operating under from the Code of Federal Regulations, but also how we dealt with operations on site, were spelled out in the Part 135 regulations, but they are also spelled out in our General Operations Manual. And in that, we use special considerations the FAA signs off on. One of the things was I couldn't land at a location unless I had communications. In some way, shape, or form, I had to be able to communicate with those people on the ground. That was always a challenge when we showed up on scene. So what radio frequency are you using? Are you on VHF or in UHF? There's a thing called simplex and duplex frequencies. If you're working with first responders, you need to become really familiar with some of these terms. If I'm on a simplex, you and I are talking on the same radio frequency, 12305. If I'm on a duplex, that means I'm talking on one, receiving on another. And that was one of those, hey, I can hear you, but you can't hear me. That's the first indication there's a problem. Then there's also what we call privacy tone codes. So what you find at hospitals but also first responders, is there's so much chatter on a radio frequency that what they'll do is they'll add a piggyback frequency that only those people that have that code can you hear. So you don't hear all that other chatter. You'd go to a hospital and you'd key the mic and they'd say, yeah, I can hear you key the mic, but I can't hear you talking. All right, what privacy tone code are you using? What's that? A lot of the hospitals didn't even know what those were. Some Motorola dealer came in and programmed that, and that was it. So I'd have to call the Motorola dealer and say, okay, what's this code? There's also analog code and digital code. And then you have to look and say, which one are we using? And they'll say, well, that's code 47. I say, well, what's the frequency that's associated with that? Well, that's 203.5. I said, no, that's not right. That's the wrong type of code. That's an analog. I'm looking for the digital because they're using newer equipment. So those are some of the issues we always ran into when we went on the scene. Now, for your purposes, you have to look at what do I do for communications on scene. That may not be direct communications via a radio because you're probably not going to have anyone on the aircraft talking to somebody on the scene. Maybe somebody, off-site. How does that work? Who do you talk to? Take into account that you're probably going to run into issues in line of sight really quickly with some of the older equipment that's in the field. The equipment that's in a lot of the states allows for 800 megahertz. Great equipment. However, it's not something you can program on the fly. You have to have it pre-programmed. So when we look at the communications tree for a state plan, a lot of times I have to get permission to get on that through the Homeland Security of the state. And that can take a while. But in that, I have had situations where I would be in, let's say, Evansville, Indiana, on the far south end of the state. And I could talk like I was sitting right next to them to somebody in the northern end of the state in South Bend because we were piggybacked on the same network on the 800. I could be on the same building as you are. If I don't have the right code, we can't talk to each other. 800's great if you're using it properly. The VHF and UHF are the ones you're going to see the most. In communication, that's going to be interesting in how you deal with it in this space, but I would always have a backup system. It's like when you're working with somebody in the field. We always had, every county has a EMS group. Every county has a sheriff's department. We had those frequencies, those radios as a backup system. We could always make something happen. Who will be communicating and who, when you're working with, it's like, who's that job? Identify that job because, again, this was the pilot command. We shared that responsibility with the medical crews on board. We had the nurses and the medics. You don't have those. So who's your communications going through? How will the communications work? What equipment is needed? Your frequencies we talked about. What's your backup plan? That's the first thing that goes out the door is communications. I don't know how many times we'll circle and circle and circle, and we'll get communications set up somehow, but we're wasting time. So figuring it out ahead of time is huge. And then when do you abort? Having that as a predetermined decision that you make at some point in your time tree. Time is always of the essence when you're dealing with patients. There are different types of patients and different times considerations. When you're dealing with trauma, it's an unknown. You're looking at dealing with the possibility of going on site to locations where there may or may not be a first responder. So triaging the patient and figuring out what could happen. Now, something that you look at is, will air transport cause more harm than good? Case that I point to is if you have someone that's in a diving accident and they have had an issue, we're underwater. If you take that patient, put them on an aircraft and now elevate them to a higher elevation, you could actually cause more harm than good. So you have to ask lots of good questions while you're going out or before you even launch. Get as much information so you can make a better decision. And that impacts the decision tree that you're working from. How long will it take? How long is too long? There was one, I turned down a flight going to southern Indiana. It's out of Indianapolis down south. It's a real right outside of Louisville. And this is, why are you turning that down? I said, well, here's the deal. The winds are out of the north at about 45 knots surface. I said, it's blowing. Yeah, we can take off and we can go, but I said, coming back at 3,000 feet, I'm going to have a headwind of about 80 knots. I said, the trucks on the interstate are going to be passing us coming home. So we can get the patient here quicker with the same level of care by putting them on an ambulance versus putting them on a helicopter. So accounting for weather, again, is big, specifically in the time frame. And then dealing with the delays, you know, we go back to that communications thing. The last thing you want is the person on the scene that called you or whoever called you wondering where you're at. Giving them feedback, you know, hey, we're taking off right now. Hey, we're 15 minutes out. Hey, we're 10 minutes out. Hey, we're 3 minutes out. You should be able to see the aircraft shortly. You know, those are huge to the people on the ground. Because I have had it happen where they didn't know and the patient started to go south. And since we didn't communicate that we were 5 minutes out, they loaded them up, threw them on an ambulance and headed the other direction, which slowed everything down. So good communications to the people you're working with is huge. And if you're going to be delayed, okay, how long is that? So you can't take off. Trying to make a decision when you have a critical patient is challenging, and I've had it, hospitals are worse than first responders. We'll wait. I said, well, it's going to be 4 hours before we can get in the air. So the ceilings, the visibility, the ice, whatever it is keeping us on the ground. We'll wait. It's a 30-minute ambulance ride. Come on. First responders, they're going to get that patient out. So there's a little different mentality when dealing with hospitals versus first responders. But again, you don't want to waste the patient's time. Working with first responders, it's a requirement. This is ironic, is as an air medical provider, I am not required from an aviation standpoint to go sit down and work with hospitals and train them on how to deal with helicopters. Most states have some type of regulation on the books that I am responsible as a first responder in their state holding a license as an ambulance provider with an aircraft. I have to do training with all the first responders. So we go out and train all the first responders. Okay, how do we communicate? What am I looking for a landing zone from you? What are the things that I can land at? What are the things I can't land at? What are some of the things you should tell me before I get there? What am I looking at for patient information? Having a check, we made up checklists and passed them out all over the place. We did what we call scene training to everybody. It just makes things run smoother, and it takes a lot of the guesswork out. When we look at like the timepiece, I was notorious for going out there with a stopwatch and looking and doing a time study. I said, is this really saving us time or is this wasting time? We had an argument in the industry for a while that's like, hey, we do this thing called a hot load where we don't shut down. We load the patient while the engines are running. And I said, well, if everything is equal, can I shut the aircraft down and get similar in time frame? So we actually did a study, and we found out the difference between loading hot and loading cold, if you did it properly and prepared for it, was about 1 minute. I said 1 minute versus the risk is, you know, that's a challenge. Now there were places that we landed, like on the interstate outside of Los Angeles, that you probably didn't want to shut down, because if you can't get it started again, you're going to get hate mail forever. And you know, it's like now you got to do something with the aircraft. You may be there for 4 hours waiting on a mechanic to show up to fix it. So there are, you know, challenges, and there's always something that's going to be different that you have to deal with. But you know, the questions in the training: who's in charge of the training? You know, having a training program, that's huge for the first responders. How do you use your equipment? How do you call your equipment? What are the protocols for bringing this equipment to the field? Who conducts the training? Who receives the training? How often do you do the training? I will tell you, in the fire, EMS, law enforcement world, there's a hierarchy. If you have the full-time people, you're looking at probably 80-20. Every year you go back, there's going to be a 20% new faces because of the turnover. When you look at the volunteer groups, it's a 50-50. Every year you go out, there's a 50% change, and you're looking at 50% new faces. So you have to keep that in the back of your mind. It's like you may show up and you just did a training about 3 months ago, And you may get the crew that hasn't done the training in the volunteer world. So that's one of the challenges we always ran into, is that the turnover in the volunteer world is huge. So having some leave behinds, having some online courses they can do, that kind of stuff has really helped out a tremendous amount. And then what standard do you teach to? So when we look at education, that's one of the things we tried to, because one of the things to get people to education, for EMS, it's a lot easier than you would think, because nurses and medics need continuing education, credits to maintain their license in their state. So if you're an accredited educator, which isn't hard to do, they will stand in line to take your education because they need it. Every year they need it. They need a certain number of continuing education credits. So that's kind of the carrot you hold out there when you're trying to do education with these people. They'll bring their little blue book and you'll sign them off and say, yeah, I gave you 2 hours of education today. Safety, safety is the big challenge. We get into that discussion, what's safe, what's unsafe. It's hard to really quantify that. That's why we do risk analysis. And when we do risk analysis, then it's based on, okay, what risk are you willing to absorb? So in the safety world, what is your safety culture? That's something that we identify early. What are your safety policies? You should have something in your books that talks to safety. We talk a lot about the incoming of safety management systems, or SMS. Part 121 world has been using that quite a bit. Part 135 world has just been told that they have to now start using SMS. There's a lot of people that are now migrating that direction. In the UAS drone unmanned systems, if it's Part 135, this applies. If it's not Part 135, it's still a little bit of a gray area, but I would highly advise looking at what an SMS looks like for your type of operation. Identifying the risk, communicating the risk, mitigating, and then when to say no. So there needs to be this loop closure. I've had some conversations with some really good friends of mine that are working in the unmanned systems today, and there was this one that I was kind of like scratching my head. I said, yeah, I can see where that was coming from, but it really scares me that you had that conversation. So the unmanned system was delivering packages, and it dropped the package on a car not once but twice. But it was never reported as a safety issue because it was reported as a glitch in the coding. I said, well, yeah, it's a glitch in the coding, but yeah, it is a safety issue. So making sure that you're capturing anything that happens off nominal so that you can actually look at it from the aspect of, well, how do we fix that? And then making sure that you have a loop closure system. So once you put a fix in, did it work? Or did it make it worse? So those are some of the things in the SMS. I do audits all the time for Part 135 operators, and that's one of the first things I look at is the loop closure, because just because you identified a problem doesn't mean you fixed it. And if you did fix it, did you fix it correctly? So I'm going to stop there and ask for questions, because I could ramble on for 8 hours, but I wanted to see if you guys, because I've done this, I've been there, I've seen it, the best policies, everything.
Yes. So what about using 4G, 5G relays? So we can work with a company called Smooth. Anyway, the company in Kitchen Wires that's 4G, 5G relays.
Right.
We work with the RCMP. I will say one of those when it comes.
I would say one of the first things I would look at is what's the coverage? If you're using it, does the area that you're supporting have the coverage that you need to be able to make that successful? 2, one of the other things is there any issues with what equipment you're using on anyone else using different equipment? So I have this conversation with the FAA. It's like making sure that there's no negatives in using this on somebody else, because when we looked at the application of 5G specifically and what that meant to air medical providers flying into and out of hospitals with instrument procedures, trying to use GPS and WAS, we were seeing some impact from certain 5G. Now, since then, we've actually identified ways to filter that out, but in the beginning, we actually did find some challenges. So I'd say definitely something I would look at. The other thing is look and say, the environment and the terrain that you're working in, the geography, and what's available. There are some places in the United States that we do business that they're very much in the dark ages. Then there's other ones that are rural and remote, and they're extraordinarily advanced and have a lot of great equipment. So good research to go through and look. It's kind of like looking at a coverage map for your cell phone and saying, okay, once I get to this spot, I may have a dead area. How do I account for that? How do I deal with that? I think you can hit the green button if you want. I'm not sure if that's, there you go.
Okay, awesome. So you touched a bit on, mentioned landing on the highway and debating whether or not to turn off the rotor on the aircraft. With GoAERO, we're looking at a lot of new technologies using particularly electric motors. How do you see what we're working on with GoAERO as smaller scale, the impact of those, as well as impact of larger scale electric aircraft that may have the lift capacity of traditional aircraft?
I think it's a double-edged sword. And the reason I say that is if you're working by chance with somebody on the site, I would say that the equipment that you have needs to have some type of sensor on the equipment that identifies when someone's in proximity to the equipment. When I start the helicopter and hit the ignition button on a turbine engine, it makes this very distinct noise before anything starts moving. And things start moving slowly until I slowly start to gain RPM. With an electric aircraft, it's not the same. I hit a button, boom, it's on. So if I have people in close proximity and I all of a sudden say, I'm on, how close is too close? And we get into the, not just the factor of impact, but also the factor of startle. There's nothing worse than watching somebody drop a patient because they were startled. So that, I would think, is something that I look at. In the electric piece itself, I think the redundancy is there, that I don't have the issue of shutting down like I would with a turbine engine. If I shut down with a turbine engine, I had it happen one time. I shut down, and we were there for about an hour and a half, but then when I went to start the aircraft, my number 2 starter decided not to work that day. So then we had to load the patient up on the ambulance, and I got to hang out for the next 5 hours until the mechanic came and fixed my aircraft. I don't know that I'm going to see that with the electric, because I think there's a higher redundancy, there's a higher, a less of a failure rate, less things to go wrong. But at the same time, I think the one piece is when you start the aircraft, it's not something that it's slow and all of a sudden people hear it and they get back. So that's one of the things I looked at and have talked about a couple of times is how do I warn the people in proximity? Maybe it's just a sensor that picks them up and beeps at them. Maybe it's a voice that says, hey, stand back, starting in 3, 2, 1, whatever that is. Again, we go back to the communications things. I found a long time ago when I'm in the pilot seat of a running helicopter and somebody starts to run to my helicopter, if I hold up my hand like this is the international symbol for, hey, how you doing? If I hold up 2 hands, all of a sudden they stop. So it's an interpretation of what it is you're trying to communicate to somebody. And I always tell my flight nurses and my medics, I said, whatever you do, never, ever run at a scene because it's infectious. As soon as you start running, everybody else starts running, and the next thing you know, you hear the pilot shutting the aircraft down because it just became unsafe. So I hope I answered your question there. Cool. Other questions? Oh, you're an easy crowd. Sir.
Lighting and stuff like that.
Lighting's a fun one, especially at night. Now, a lot of times we'll go to a scene, there's more light than you can shake a stick at because it's an ambulance crew, probably several fire trucks, sheriff's department. Sometimes I have to tell them to turn the lights off. Now, if you're going to a site that's remote and there's no one there, that could be a challenge. So I would say when you're working with sensors, definitely look at infrared. In the EMS world, we flew a lot under night vision goggles, which were a huge help in some of the environments we went into. There are some equipment out there for IR as well. Going into certain areas, one of the things I found was, okay, if I'm using this equipment, is there any type of lighting that interferes with that type of equipment? So I'm shooting an approach into a hospital, I'm wearing night vision goggles. If that particular hospital has floodlights that are incandescent, like a mercury vapor light, it will shut my night vision goggles down because of the intensity. On the other end of the spectrum, if they're shooting lights that are LED, LEDs are an extraordinarily focused nanometer wavelength compared to incandescents, which range from ultraviolet all the way to IR. There are certain LED lights, if you look at what the FAA wrote for their engineering brief on obstruction lighting, we convinced them several years ago that we need to put an IR emitter, because at normal obstruction lighting, I can see under normal vision 30 miles away. If it's an incandescent light, I could see it 30 miles away. If it was an LED light, I couldn't see it until I was about a mile out, because that particular type of equipment, those goggles, that particular gating on the goggles was such that it wasn't sensitive to that particular wavelength. Green light is what we use for marking heliports. If you use a green LED and there's nothing else, you'll probably see those within about 200 to 300 feet. If you have a green light with a green lens, it's damn near invisible until you get within 3 feet. Blue light, blue lenses like taxiway lights, you could stand right there and you can't see it. It is totally invisible. So knowing what the capability of your equipment is when it comes to lighting is huge, because you may get there, it's like, well, I don't see anything. Or you may get there and say, man, I can't see anything. So it's one of those challenges we get into, and when we talk to first responders, we always tell them, it's like, hey, don't shine light on the aircraft, you blind the pilot. I have fortunately never had to deal with laser strikes, but I've had friends who've had to deal with that. In most cases, nefarious people doing stupid stuff. But lighting is definitely something that we look at. And then on the educational side is, how do you want your landing zone set up? If you're pinpointing a landing zone at night, how do you want that set up? So it's like, how big is it? How do you mark it? How many lights? So we have, if you go to the Aeronautical Information Manual, Chapter 10, in there in Section 2, there is a section on helicopters off-site operations. The section was written by the National EMS Pilots Association of how to set up, mark, and light landing zones in off-site environments. The FAA liked it so much, they asked National EMS Pilots Association if they could put it in the Aeronautical Information Manual. Great foundation for that.
I think I was asking a different question, because the camera systems we have can handle a lot of those problems that you could not handle with night vision.
Right.
Didn't we? I was more like asking what kind of lighting you need to have on the aircraft or drone.
Okay.
So that we register requirements and stuff.
I would say for normal operations, just like any aircraft, you have your navigational lights so that when you're coming and going, people can tell which side's right and left. And then you may, and this is one of those questions you would really need to look at from the aspect of both a federal regulation as well as the state governing authority for EMS. Normally that's Homeland Security. So if you look at the licensure for a state for a helicopter, there is a criteria on the books that mandates, like in the state of Indiana, Kentucky, Illinois, you have a landing light. And they even give you a candle power. So that's something to say, hey, do we have to have that? It's like I have to have a 300,000 candle power light for a landing light. Some states say, well, it's got to be steerable. So that's one of those things when you're using equipment in different states. Is that apply to us? If so, how do we make that happen? Some of those lights are big and heavy. Weight's a big deal. So that's, I think, on the lighting side. Now, once you're on the ground and you're moving patients around, do you have enough light to do that safely? So as in the back of the aircraft, we have these load lights. They're white lights that we flip on. So when we open the doors up, we can see loading and unloading the patient clearly. So I would say that would be the other piece of what I would recommend. Sir?
With all the different fly designs being electric, primarily, can you hear me all right?
Yeah, just pretty close, yeah.
Okay.
Remember, I flew helicopters for 40 years.
With all of the different fly designs, most of them being electric,
Right.
and deployment time being such a critical factor in emergency rescue, do you see there being any real advantage to how fast you can deploy one of these flyers as compared to a conventional rotorcraft? What factors would those have?
As far as deployment, just as an example of what we looked at in the aeromedical industry, so the expectation of most of our bases, everyone's a little bit different, and part of that's aircraft specific, geographic specific, weather specific. What we used to use was a rule of thumb that our expectation, if the weather is good, when you got the call to take off, you were in the air in 7 minutes. That was the expectation. If the weather was questionable, we looked at 10 minutes because we looked at you to slow down, check the weather, validate that you have the weather to go. Now, part of that, when we looked at weather, how we applied weather was based on how the FAA defined local versus cross-country. So the FAA defines cross-country as anything greater than 50 nautical miles. So when we looked at that, if you were in the flatlands of Midwest, your local area was a radius of 50 nautical miles. Now, if you're in the mountainous terrain, they actually shrank that down to 25 miles. For us, when we said we had green weather, that meant the weather was good to go anywhere within our local area. If I had something greater than 50 miles, it was understood that that had to be a mandatory weather check because it's really hard to keep track of the weather in that big of area because our range in the helicopter was generally out to 150 in any direction. So between 50 and 150, that was an automatic weather check. Now, if the weather was questionable in the 50 miles, we were yellow as well, which mandated a weather check. So green, I would be off the ground in 6. Yellow, I'd be off the ground in 10, with the caveat, the farther the distance, the greater the weather window necessitated. So that's the challenge. Now, I guess the question there, and I'd ask of you and everybody else in this room, what's the distance you expect these aircraft to fly? If it's not greater than 50 miles, it's probably not going to be an issue. I'm not sure if we're looking at 20, 40, 50 or greater. That's where we get into, if I'm looking at the weather and I'm going 50 or 20 miles out, 20 miles back, I can do everything I need to do from the time I get the call to the time I come back with the patient about an hour or less. My weather window is this. I can track that really well on what's going on for the area forecast and how the weather's moving. There were times that I would get called from Indianapolis to go to Cleveland. That's an hour and 40 minutes. Then I'd be on Cleveland for like 2 hours. Then an hour and 40. My weather window is much larger. So now I got to look and say, okay, well, the weather here now is, and the weather in Illinois is, and by the time that elapses, where's that weather at? So there's a lot more challenges in figuring out the time. But to your initial question, I would say deploying for us, the average for the local was 7. The average for the cross-country was 10. The only time that changes is if it's a specialty team and requiring special equipment. So if I was doing normal trauma, normal cardiac, that was in the equipment that we had on board already. If I got the call to do a neonatal transport, I now needed a specialty team. I had to unload the equipment that I had on there and put the specialty equipment, which was the isolette. We dial that in our protocols and account for that in our timeline.
So just a quick follow-up to that. Those timelines you mentioned, it sounds like the weather is the biggest factor in how much you have to extend it, but that base cap in the 7 minutes, is that going to be fueling and all other ground operations, or?
Well, when pilot comes into work, their first job is to check in. Once they check in, the clock starts because pilots have a duty time. So they check in, then they go pre-flight the aircraft. That's their first priority. Then they come and they check the weather. Once all that's done, they make sure that they have the fuel on board and they have the weather they need to fly anywhere within that local area at a moment's notice. So they're doing all this prior. So there's not, once I get that, hey, you got a flight, unless I'm coming off another flight, I should be ready to go at a moment's notice. It's like a fireman. Yeah, it's just like the bell goes off, you go run it. So everything's already done. Now, one of the things that we do in the helicopter world is this came from the military, and the military phrase is we do what we call a combat cock of the aircraft. So we do our pre-flight. Well, that's part of the checklist, but the other part is the run-up. I'll do all the checks for the run-up up until the point where I pull the trigger to start the engine, and then I'll turn the battery off. So I've done half of my checklist for run-up already. So once I get in the aircraft, I turn the battery, finish that. What that does is shave about 2 minutes off my start time. So there's things that you can do and sequence in so you're not doing end to end, you're actually overlaying. And that's the key when you're trying to get off the ground quickly is what can I do ahead of time that when I do get called, I can launch quicker.
Sorry,
Are we at the time?
yes, we are.
That was quick. Thank you so much. And Gwen, thank you.